dominoes falling, pushing walls, and the Newton's cradle. These are all examples of Newton's third law. Newton's third law states that for every action there is an equal and opposite reaction.
Every action has an equal and opposite reaction. This means that when you're pushing on something, it exerts an equal amount of force and reacts in an equal manner. Dominoes falling over have all to do with this law. When you push on the first domino, it falls. When that domino falls onto the next, it transfers its energy to the next domino. Then the next domino falls on the next one, and so on. The third law of motion has a very active role in the domino effect.
The Newton's cradle is another great example of his third law, because when one ball hits all the other ones, the force exerted travels through all the middle balls until it gets to the other side, where it makes the far end ball move because of that force.
Pushing a wall is a good example of Newton's third law, because pushing the wall is an equal force. The opposite force is the wall pushing back at you. The wall gives off as much force as you give in. If the wall was not sturdy enough and collapsed due to your force, the opposite reaction would be the wall falling over. In conclusion, Newton's third law is very important for explaining actions and how they react. It is shown in a lot of real-world motion and has a major impact on how actions react.
Friction is the resistance of motion to rolling, sliding, fluid, and static objects. For demonstration purposes, we will be covering sliding friction and rolling friction.
Rolling chairs on a carpet and tile is an example of rolling friction. Rolling a chair on carpet has more friction and more resistance from motion. Rolling on tile, however, has little friction and allows the chair to have more motion.
A match with a matchbox is a great example of sliding friction because of the smooth surface of the match is sliding against the rough surface of the box, and it provides a frictional force proportional to how fast the match is moving on the surface. This friction creates enough heat to start a combustional reaction.
In conclusion, friction has a lot to do with motion and plays a very big role in it. From slipping on ice to striking matches to rolling on chairs, friction can change motion in many ways.